All right, we have wave mechanics. The wave model, mechanical waves and longitudinal movement. Mechanical waves produce physical results when they move. They still may not see the wave itself, but will see the result of it moving. Example, earthquakes or ripples in water. Longitudinal movements. The particles of the medium move parallel to the direction in which the wave travels. In longitudinal waves, the medium is parallel to the wave. This is different than transverse or horizontal wave movement, where the medium is moving perpendicular to the direction the wave is traveling. Our materials and methods. Our experimental materials include one slinky, one surface for the slinky waves, which was buffed and finished concrete, and a tape measure. Our methods and procedures for the experiment. The slinky was stretched to a length of 5 feet with 3 different tensions. Tension was increased by limiting the length of the medium that was stretched to 5 feet. Excuse me. The minimum tension used the full medium of the slinky, which was 2.5 inches tall when compressed. The second level of tension was created by decreasing the length of the medium to approximately 1.875 inches, therefore increasing the elastic force and tension acting on the slinky. Each video was recorded for roughly 10 seconds each. What we predicted. We predict that as you increase the tension of the slinky, the velocity of the wave traveling through the slinky will also increase. How we kind of came to this conclusion or this prediction is from tension determines vertical force perpendicular to wave motion on the slinky, and therefore determines the speed of perpendicular motion in the slinky. So here we have the least tension for the slinky. Here we have medium tension of the slinky. And here we have the maximum tension of the slinky. So our data for the slinky with the least tension, here we have the time versus velocity, and we did it in increments of 0.02 seconds, where we got an average velocity of 3.88 meters per second. Here you can see how we analyzed the wave speed through different points for different frames. We did a similar process with medium tension and marking the different points of the wave through different frames. With this, though, we see a slightly higher average velocity of 5.96 meters per second. So slightly increasing from the slinky with the least amount of tension. And last, we have the maximum tension obtained the same way as the other two. And we get an average velocity of 9.29 meters per second, having the highest velocity out of any of the slinkies. Observations. After thorough experimentation and results gathering, we found that the more tension on the slinky, the faster the velocity was, or the greater the velocity was, rather, even as time had gone on. We had theorized this before we had started our experiment. That was one of our predictions, so our prediction was correct. Conclusion. In conclusion, it can be seen that the tension of a slinky represents the speed of a wave given the proper limitations and other factors, and therefore our initial prediction was correct. Thank you very much.